Hello and welcome to the Smart Forestry webinar series. We are now on episode 3, following the introduction of the Smart Forestry and the digital inventory methods and how to capture that data on a tree level. Today, we are focusing on the simulation and optimization of that tree level data. My name is Jani Kaskinen. I'm Senior Principal in AFRY Management Consulting, Bioindustry sector. And with me, I have Jussi Rasimäki and Antti Mäkinen. Welcome.
Thank you, Jani. Welcome on my behalf as well. My name is Jussi Rasimäki and I'm CEO of Simosol.
My name is Antti Mäkinen and I'm the COO of Simosol. Happy to be here.
All right, thank you. So we, in the first episode, we were looking at the whole concept of smart forestry and the different elements of that. And as said, we started with capturing that tree level data, monitoring the potential damages and pest disturbances within the forest asset. And today, we're looking at the simulation and optimization on that tree level data. Simosol is born and raised as a company for around simulation and optimization. We also look at the predictive analytics and site-specific management. By that, well, Jussi, a few words about the predictive analytics.
Yeah, if I start with the first line, simulation and optimization alone, so we have a kind of broad perspective also on history. In this session we talk about the general principles of forest management planning using simulation and optimization as tools, but then we get to the kind of cutting edge in that sense that we are not looking at simulation and optimization as a one-time activity done in isolation, but really a kind of a learning process where this new kind of input data to the simulation and optimization and planning really helps. So predictive analytics, building a kind of a learning platform on this topic and feeding the information from the past to make future predictions. And then also site-specific management, how to manage the forest, not by the book, not strictly according to the guidelines set some time ago, but really kind of focusing on what we are learning from the data that we are gathering in the inventory, but then also from the execution of the operations and adjusting our actions based on this data pool that we are gathering.
So the site in this context is not the same as a compartment or stand as it traditionally has been. We're really talking about dynamic creation of the management units.
Exactly.
Yep.
Exactly. That's one part of the not doing it by the book, not relying on some borders set, for example, well, typically when the trees are planted, but really looking at the dynamic situation and adjusting also the management units based on the data that is being collected.
Yeah. So let's start with why we're doing the forest planning overall and how it's done traditionally versus how can it be done with these new methods, how the tree level inventory data then translates into the forecast and a planning mode. Talk about optimization in a strategic level, geospatial optimization, predictive analytics, and then close up the webinar with some take-home messages, key points of this webinar. So purpose of forest management planning, or planning in general, I think one good thing about not planning things is that unpleasant surprises come as a surprise and you don't really have a time to worry about them, right? But in this context, we have a forest assets and we have a certain values and needs around them. Jussi, please.
Yes, for that part of the audience that has been following the webinar so far, we have been so far focusing on the left-hand side on the forest resource data and what has been changing, how it and is changing, how it is collected. But then planning really marries two things together. You need to know what you're doing your planning on your assets, but then also need to identify your values and needs, because you are doing planning for something. You have a goal, you have an objective for what you want to achieve with what you have, and this is really the core of the planning process, knowing what your goals are. Because no one in this world works in an isolation, there are also constraints. Well, there can be constraints set by yourself as well for your activities, but usually these come also from the surrounding environment, from the legislation and for the market situation, etc., etc. So those two things affect a lot on your planning, or actually those three things: your forest resource data, then your objectives, and then the constraints. And what we are talking about planning, the approach we are covering today towards planning is really this kind of a quantitative planning using simulation and optimization. So mathematical optimization is applied to our resource data so that we are kind of forcing our objectives and constraints on the optimization problem. And this then results in the selection of strategic level management plan. So strategic level in forestry context, typically we are targeting at least one rotation, which decades in the northern latitudes and then years in the tropics. But the strategic level is, regardless how long your long-term view is in years, it is about the long-term view of the utilization of the forest resources. And that is useful on its own right, but when we are then thinking about the kind of real life utilization of these planning results, it can be problematic to really execute the strategic level plan. It may need, you may realize from your strategic plan that, okay, maybe I need to adjust the objectives and constraints a little bit and create a new plan. So usually planning is not a kind of a straight line process. It is a iterative process. You go back to your definition. But once you have selected your strategic level plan, this is what I want to execute, there we may come into a problematic situation that the strategic level plan is really not feasible to be executed in practice. And typically that then leads us to the second step of forest management planning, tactical planning, where we really need to take into consideration how the actual operations in the forests are carried out. And these are the two levels of planning that we are covering in today's seminar: how the strategic level plan is generated, and based on that, how can you then generate the operational management plan that you actually can give to someone and say that, okay, please carry out these operations, let's go, let's execute.
Right. That's good. Then let's look at the differences between the stand and the tree level measurements and how that affects. Antti, please.
Okay, thanks, Jani. So basically, planning is generally about somehow projecting into the future what will happen, for example, to the forests. And that's at Simosol we do with different types of forest growth models that allow us to estimate the development of the forest and also help us in evaluating different kind of alternative actions that we can do in the forest, such as harvesting. traditionally, forest growth models have been fairly simple. Everyone working in forestry more or less knows what a yield table is. Yield table is a very simplified and a traditional way of modeling forest growth. It basically tells you what any given forest stand will be at a certain age. The good thing about these yield tables is that they are really simple. They are really simple to apply in practice, and I think that's why they are loved by practitioners. But the downside is that they are too simple. They give us a very simplified picture of the reality. When we are looking at different types of models, we are typically talking about stand level models or then tree level models. At stand level models and yield tables, the forest growth is predicted at single stand level. But with the tree level models, you actually can predict how each tree in a particular stand will grow and develop over time. These tree level model and even these spatial models, which take into account the actual locations of the trees, they have existed actually quite a while, especially here in the Nordics. We've had these single tree level spatial models available for a few decades already. And thanks to very active and kind of world-renowned forest research. The problem before has been that we haven't really been able to utilize these tree-level spatial models that much. And why is that? That is because we haven't had the tree-level data available. Traditionally, from forests, we've been estimating these stand level averages. You know, what's the mean diameter, what's the mean height, how many trees on average we have per stand. With this kind of data, we can use either stand level models or these little bit simplified tree list models. But nowadays, when we can using single tree level inventory, we can get single tree level wall-to-wall inventory data from all of our forests. We have the possibility of utilizing these spatial tree level models. So in short, we've had the models already for a while, but we haven't had the data. Now we do have the data, and we are in a kind of a crossroads where we can really start doing the forest growth modeling at tree level.
Yeah. So on that, let's say traditional calculating averages, then of course when you apply forecasts and simulation, you end up with some sort of averages. Fair statement.
Mm-hmm.
All right, let's talk about that a little bit. How do you simulate the growth and how does it all work? And I guess it's very different from very different environments, species, all that.
Yeah. Okay, so this is a very typical example of applying these so-called tree list models or tree level models, but which don't require actual tree level data to be measured. So what we've been doing, let's say here in Finland for a long time already, is that when we get this stand level average data, we simulate the trees to the forest. We haven't had the tree level data before, but we have these so-called distribution models which allow us to simulate the trees or the kind of a tree size distribution to the of each stand. And then we can apply these tree level models to each of these three dBH or diameter classes in our simulation data. Here the picture shows a typical kind of a distribution of tree diameters within a one stand. And this is typically what we are actually simulating when talking about these forest models.
All right.
Okay, so basically we apply these tree-level growth models to each of these diameter classes in this distribution. Here's an example, or kind of an example arrow shows one of the smallest diameter classes. They're at around 10 centimeters. And when we predict the forest growth, let's say over a year, for example, so we predict how the forest grows over 1 year, and do that with the tree level models. This distribution kind of moves right, and it's basically just because the trees get bigger, the diameter increases and the distribution moves right. Why we are actually doing it this? I mean, this might seem like overcomplicating things, but there's a good reason for doing the simulation like this. This approach allows us to simulate the different harvests that happen in the forest very accurately. So here in the right-hand side, the third image, we are kind of showing how a thinning is simulated. So in a lower thinning, typically, you remove the smallest trees from the stand. And basically, when looking at or putting that into this kind of a mathematical description, you remove the smallest trees from the distribution. And now we get actually a much better description of what kind of trees were actually harvested from the forest and what kind of trees were not harvested. So it gives us a much more accurate description of the trees, and therefore also the timber products that were harvested, but also on the situation in the forest after the thinning. So this is basically why we are and have been doing for a long time this forest growth modeling at the single tree level.
So how long you've been doing the growth modeling? You have a bit of a background on this topic.
A while. So this is kind of related very much to my PhD work, which I did before we started this company Simosol 13 years ago. So I would say long enough already.
Longer than you care to remember.
Yeah.
That seems like dedication for the topic. Yeah. All right. So then let's talk about the tree level modeling.
Okay. So in the previous slides, we were showing how things have been done using this stand level average data. For example, here in the Nordics countries. Now, when we get this actual tree level data, where all of the trees in the forest have been measured, this gives us actually a much better starting point for the simulation. First of all, we don't have to model using these distribution models this size distribution. We know the actual size distribution in the forest. So basically our distribution is real, not modeled, and we know exactly what kind of trees we have in the forest, and when we apply these tree level models and simulate, for example, the harvests, we get much more accurate description of the timber products, for example, that's or assortment or whatever you want to call it, you get much better description of the assortment yield of the harvest. And why do we want this? I mean, forest planning, although it's super interesting on its own, but usually in most forestry companies, it serves some actual business needs and a purpose. For example, these short-term harvest forecasts are quite often utilized by the either the production department of the company. So if the company is, for example, running a sawmill or some other processing facility, they want to know what kind of material they will get this year, next year, and so on. In some other companies which don't have their own processing, their clients want to know what kind of timber this company can supply. This kind of data gives us much better visibility on the timber that can be provided in the short term. I would say that this is one of the kind of key points of this tree level data.
Right. Okay. So we can imagine there is a lot of scenarios that can be applied. So if we look at the northern forests and the cycle of 50 years, or in a plantation environment of 5 to 7 year cycle, there's quite a bit of happening and different options that may happen. Jussi, can you say a few words about that?
Certainly. So now we are really getting to the planning part. So what Antti just described is kind of the mechanism and mechanics in how we are able to look into the future of the forest or the forest area under planning. And this, what you see here, is the kind of principle how this mechanism is applied for in the planning context. So we have a singular starting point, what we have in the forest right now. And then we start to go into the future in time, forwards in time, and we start creating alternative scenarios, what ifs. What if we harvest next year, or what if we don't harvest next year? What is the development of the forest asset, the forest resources, how the trees grow in future? If we do this, if we don't do this, if we do that something else, if we don't do that. So we get the kind of what is called a decision tree, where we have over time different alternatives for the future state of the forest. And
so
this
your technology then kind of works opposite way around. So if I want a certain end result, or I want to maximize a certain end result, then it will look all of these scenarios and find the optimal way of. Okay. Yep.
Exactly. So the role of, we have two parts in this planning process. We have the simulation, and then we have optimization. The role of the simulation is to kind of map the unknown. So map all the possible future scenarios. We could do like this, or we could do something else. And then the role of the optimization is choose one part in this decision tree, which you can now see on the screen with this kind of highlighted arrows. So and each of the one ball in there, it describes a management unit, one management unit. Then we multiply all these decision trees over all management units. But we are now looking at the single management unit, and the optimization chooses the optimal future path for that single management unit by kind of, and how the optimal path is expressed, it's the timing of the operation. So in this case, the next step for this management unit is harvesting, and then the establishment of a new tree generation. And the kind of overall plan is a combination of these optimal paths for all of the management units in the planning area.
Right. So let's assume that we would have a forest assets potentially all over the world. So there's a lot of species, a lot of different growth cycles. You can do the optimization for the whole asset base, or do you have to do it by area at the time?
It can be done for whole asset base. It depends. It varies a bit. It's kind of typical that you do you have a portfolio of assets. You do individual asset planning, but then you can do this kind of whole kind of portfolio planning as well. It depends a little bit on what are these all assets in the same market, for example, or do you want to do your planning based on a single market where part of your assets are, etc., etc. But the kind of whole concept of this planning, it doesn't limit you in how you apply it. How you apply it pretty much is dictated by the practicalities.
Right. Okay. So, and that gets us to the core, which is the strategic level planning, right?
Yes. So here we are looking at the outcome of two different plans, strategic level plans. So what we have on the x-axis in the charts is the year. The year is running from the present date to the end of the planning scenario, planning horizon. And somewhat kind of strikingly or controversially, what we have there in the y-axis is actually cash flow. Typically, when foresters talk about strategic level planning, the first attribute we are talking about is cubic meters. So how many cubic meters per year are we harvesting? But actually why the harvest happens is it's about the cash flow and generation of the cash flow. So hence here in this example, we are actually first looking at the cash flow, and the two plans are not very much different from each other because they both start from the same starting point. We have the current asset and the attributes of that asset. We have a certain age distribution over the asset, for example. So the plans typically aren't entirely different, but there are differences here. We can see, for example, that in 10 years time in this case, or actually more like from 5 years from now, in the scenario 2, in the second plan, there is actually quite a peak in harvest level, which then causes this peak in the cash flow. Typically, that's a pleasant problem to have, a lot of cash flow coming in, but it can be that this is not really realistic in the kind of market sense to really kind of unload a lot of wood into the market in one specific year. So the scenario 1 in this case is a kind of even cash flow plan. So we have put in there a constraint that the harvesting level and hence the cash flow influx can't vary too much from year to year. And then the kind of whole point of these different alternative plans is to compare them with each other and see what is the practical effect of this kind of constraint on our operations over longer term. What is the effect on the net present value of the asset if we have to put such a market constraint on our asset? How will the net present value of the asset change in that case? This kind of comparison between the possible futures.
Right. Go on.
Yeah, I'm just going to continue straight on to the how do we actually know what the cash flow is? Where does the cash flow come from? And that is shown in the next picture, next charts, which is, of course, this links back to what Antti presented and highlighted. The cash flow actually comes in this case from timber sales, roundwood sales, and the different assortments of timber being sold. Pulpwood has a different unit price than a sawlog, quite a bit different actually, and that has a huge impact on the cash flow prediction. So the simulation, all those complicated, well, maybe a little bit complicated looking distributions of different sizes of stems, they actually all link to this picture, because then when we are doing the simulation at such a level, we can then say that, okay, year one, you get this much of spruce logs and this much of pine pulpwood, etc., etc. And this is also kind of the very strong link to the point that Antti made about the improved accuracy of the input data. If we know what the trees are that we are actually simulating, then we also know what kind of timber assortments come out in the harvest, and we then can say that then the cash flow will be like this. And this then links to something else that we haven't touched upon too much so far, but it's about the different management practices. And this allows us to evaluate that if I, for example, apply longer rotations that yield us a little bit more saw logs, but overall maybe a little bit more lower total yield, would that be profitable given a specific price development scenario, for example, over time? So we can couple into this planning process not only the trees and the owner goals and constraints, but also the other aspects that affect the ultimate yield of different timber assortments, and hence the yield of the cash flow. So pricing, management activities, do we do thinnings, do we do only clear cuts, how do we time the thinning, what is the intensity of the thinning? So really kind of different management styles, different management activities, scenarios are also one integral part of this kind of strategic level, because it's ultimately answering to the question, how should I function with my forest assets over a long period of time?
Right. And let's say this is kind of, we're looking at this example kind of like a forest owner view, if that's the right way. But what if I have a forest assets and I have a few pulp mills and I just want to optimize the wood flow based on the demand on those?
Yeah, forest management planning in that aspect, it's a coin. So on one side of the coin, you have the forest owner and their goal of basically typically maximizing the net present value of the asset looked at from the point of view of the timber sales around wood sales. And on the other flip side of that coin is the utilizers of the timber and the wood flow from the forests. There the goal is typically to minimize the mill gate price of the wood, but also secure a constant flow of wood to the mill, because that's then, if you kind of really minimize just the unit price of the timber coming to the mill, you may end up with the situation that, okay, you get really cheap timber for 1 year, but the next year you don't get any timber, and that would be rather costly exercise. So right. Then this kind of you can apply the same planning process for both sides of this coin. It's just the kind of different, you will probably have a different goal to optimize against, but essentially you are still considering the same resource base and how it will be utilized.
Right. And then coming to so this is how you can optimize in this level, and then let's say that your plan is to get certain kind of timber and maximize that, but then you have a problem that yes, you have it, but it's kind of all over the place. How do we go about that? Because operationally it might not be the most optimized way, right? So as an example, there is a situation where we have the optimized results all over the map. Antti.
Yeah, sure. So let's say traditionally in this strategic planning, we are more focused on the big picture and the longer term, but we are not paying that much detail to the or not paying that much attention to the detail and the kind of short-term operational feasibility. And this is very typical in strategic planning, also in the optimization methods and optimization models that are applied in strategic planning. Those are not usually spatial or geospatial optimization tools. And it basically means that these harvest plans from a strategic plan are quite often look like they were, somebody has shot with a shotgun there all over the landscape. So the harvests are all over. Well, what does this mean in practice? It means that in practice, when you look at a higher level of detail, your strategic plan cannot be adapted maybe directly to your short-term operational plan. So these harvests are here and there. The harvest blocks might be way too small to be harvested alone, because there's a certain fixed costs usually related to accessing a site, and roads you need to take into account, and all of that. So basically, quite often you cannot apply your harvest plan at a strategic plan as an operational single stand level plan. But there's luckily a solution to that. So there are spatial or geospatial optimization models which allow us to optimize in a shorter term. We take our let's say, for example, annual harvest budgets from the strategic plan, but then we look at a shorter time span. It can be year, 5 years, 10 years, depending on where we are. But we are typically looking at the shorter time period, but we are paying more attention to the spatial kind of a pattern of the harvesting, and also the different costs related to the road maintenance, logistics, and so on. And quite often we want to find harvest blocks that are large enough so that the fixed costs involved in all harvests are spread over a larger continuous harvest block. And here in this picture we see kind of a example on about the same amount of harvested volume coming from only a few kind of these harvest blocks, which kind of aggregate these harvests into smaller areas. And this spatial optimization is quite important part in making these strategic plans more actionable. And this we have been coupling also with road investment planning and road maintenance planning.
Right. Sounds good. Sounds pretty complicated as well, if you ask me. But basically, now the system takes all of that strategic plans and applies it to a more manageable units, obviously reducing the operational cost and make it more manageable. How does that then, does it do this year by year? So the next year would look like same, so there's a few concentrations of harvest.
Yeah.
Yep.
Yes, but of course planning is a continuous process. So typically you would, for example, this tactical operational plan, you would be updating it at yearly or even monthly level. So depending, I mean, of course, one important thing to understand in the planning is that plans can sometimes go wrong, even though they were even if the plans are great, they still something can happen that you must kind of adapt to, and then you need to replan and so on. But the idea is that we have a continuous plan and kind of a roadmap on what to do.
Right.
And one aspect to take into account here, typically at the tactical planning, is it's very, I would say, almost rare to do it at the year resolution, because if you have seasonal aspect in your operation environment, like we have, for example, in Finland, well, last year not so much of winters anymore, but this year luckily we have had the proper winter. So if you have a seasonal variation in your operation environment, then it is already typically taken into account in the tactical planning. Not so much in strategic planning, but in tactical planning, yes, because we are, for example, considering the transport of the wood to the mills, and then, for example, part of the road network may not be usable for all seasons. So we really need to consider this kind of seasonal plans, or even monthly plans within the seasons also. So the time resolution can really kind of vary at this level of planning quite a lot.
Right. So accessibility is one of those things, and and in this plan there's also some roads plans. So you have or the user can apply some cost parameters on the building the roads and.
Exactly. So access to the forest asset is definitely a crucial aspect of tactical planning, because it quite often is the case that you may have a good forest asset providing the raw material that you are interested in, but there is no access to it. So for forest road construction is one. If that is the case, then forest road construction is definitely one part of this planning step.
Right. Okay. So going back to that predictive analytics topic and how that works, I guess it's a continuous process and a loop. So Jussi, please continue. I can open up some pictures for you here.
Yeah. So indeed, because you can get the kind of false impression from this graph alone that it is a kind of a linear process, that you start what you have and then you make the predictions to the future, then you choose your optimal paths for each decision unit, each management unit. Yes, that is correct for a single activity, but then it is, of course, like Antti already mentioned and highlighted, that this is a continuous process. What is a little bit lacking in most cases, I would say, in current activities, to how do you learn from the past? It's a kind of, yes, you do the planning repeatedly, but do you really take into account what you have planned previously and how it was executed? Do you take into account the previous inventories, what you learned from the forest there, and do you apply then that against what you were harvesting, for example, from the forest? This is not so commonly done nowadays, but it is something that definitely will be done in the future, because here we are getting to the predictive analytics. We need to build these feedback loops from the different steps in our whole planning process, also covering the inventories, that then help to improve our predictive models, make the models a little bit more learning than what they typically are nowadays, utilize the data from the operations to again enhance what we are predicting for the future, and also then especially in the tropical plantation setting, couple the information for the R&D activities for the genetic material that we are using in the plantations, to kind of tie the sites where the material has been used, how it has performed there, combine that information then to arrive into site-specific management. So meaning that we know that we are using this material on this specific site that has these characteristics, hence we need to manage the site like this. So it is all this predictive analytics and site-specific management is all about this kind of iterative, continuous loop learning process, where we are collecting the information and making sure that we are utilizing the collected information when we are doing the next round of planning.
Right, and that's a lot of data, but it sounds really fruitful ground for AI to be used. So if I think of the inventory that you have now, there might be some errors still, even though that you do it really well. But then you have a harvesting, for example. If you feed that data back to the origin, then you get more. You got one more data point to kind of validate the answers. And I guess it goes same with all the silvicultural work and every kind of touch point there is.
Exactly.
And also that whole feedback to the R&D, so that this particular tree didn't grow that well in this particular environment, right?
That's right. Exactly. But this again, there is a link to this kind of a circling back to the concept of having quite accurate input data in the first place. I think one of the reasons why this kind of predictive analytics and site-specific management hasn't really taken off so far in forest management is that the kind of granularity of and the accuracy of the input data in the first place hasn't really been at the sufficient levels for that to happen. But it's kind of it's not a vicious circle, it's a circle, good circle, that when you improve one aspect of, or if you improve the starting point of the whole process, then good things may come as a result of that in the future.
For sure. Then continuing some of the key takeaways, we are reaching the end of the webinar soon. Jussi, please continue.
Well, I already pretty much went through the first take-home message there, that simulation with reliable data and dynamic learning models is, I would say, the backbone of future forest management planning. So that is the kind of really one of the key messages from this session. We are actually good for the second take-home message. We haven't touched upon this aspect so much in this webinar. This is actually something we will be discussing more in the, I think it's in the last webinar of the session, but the kind of different objectives, different levels and timeframes that we covered in this seminar. So strategic planning and operational or tactical planning. But then one aspect for the next or coming webinar is still then also about the differences in objectives.
Yep.
Again, the kind of three-level data that we already went through just a moment ago. So really just highlighting that when you improve what you start with, then you can really leverage that improvement in the further steps of your planning process. And then exactly the learning aspect and the continuous planning aspect of it. It's not a single time activity. It's an activity that you will repeat all the time in your operations. Then, since the fact is that you have such a process, making that process to be learning so that it can be improved continuously, I think that might be a very good idea.
Right, and I think the learning also goes with your growth modeling. The loop improves.
Exactly, that's one aspect of it. They are a kind of central piece in this simulation part of the planning process. And if you are able to feed back information to that, then you are definitely improving a kind of core part of your planning process.
All right. So we reach the end again, now pretty much on time, unlike the previous shots. But next webinar we have is in April 13th, and we're going to discuss in supply chain management and how you, first of all, visualize and manage the operations around that. And then what Jussi also mentioned, the last webinar is then kind of wrapping everything together and looking at the dynamic modeling of the whole value chain and what's possible. I want to thank you all for joining us. There's again a lot of you, and if you have any questions, you can drop them directly to us or in the chat box here. And looking forward to see you in the next webinar with us. Thank you.
Thank you very much. Hope to see you.
Thank you. It was a pleasure.